Okay, once again, we're breaking this into part A and part B. And in part B, once again, we're looking at how to solve the equations. A good place to start is always getting everything on one side of the equation. So let's subtract 3b squared from both sides. So I've got 15b squared minus 19b minus 8 equals negative 5b. And I'm going to add 5b to both sides. You could have done both at once, but I didn't want to confuse someone. Negative 19 plus 5b, negative 14. So we are looking for factors of 15 times negative 8, so negative 120, that give us a sum of negative 14. So I'm going to look for a difference of 14 in my factor t. Okay, I'm not going to do 1, 2, 3. Let's just start with 4. 120 divided by 4 is 30. Okay, so far I'm 26 apart. 5, 120 divided by 5 is 24, so I'm only 19 apart. We're getting there. 6, oh yeah, 6 and 20. There we go. So I've got 15b squared. Oh, let's do positive first. Plus 6b minus 20b minus 8 equals 0. Greatest common factor of the first two terms is 3b, so I'm going to have 5b plus 2 left. Greatest common factor for the next two terms is negative 4, and surprise, surprise, I get 5b plus 2 there also. So my two factors are 5b plus 2 and 3b minus equals 0. Next, we can use our zero product property. So either 5b plus 2 equals 0 or 3b minus 4 equals 0. So if we subtract 2 from both sides, I have 5b equals negative 2. Divide both sides by 5, and I get b equals negative 2/5. And add 4 to both sides. 3b equals 4, divide by 3, and b equals 4/3. Those are our two solutions. And since we spent so long on one problem, I'm not going to take the time to show the check step. We've done that quite a bit. You can do the check step nicely on your calculator. Miss Nugent's science class built an air-launched model rocket for a competition. When they test launched their rocket outside the classroom, the rocket landed in a nearby tree. Rats. If the launch pad was 2 feet above the ground, the initial velocity of the rocket was 64 feet per second, and the rocket landed 30 feet above the ground. How long was the rocket in flight? Use the equation. H equals negative 16t squared plus vt plus s. Well, unfortunately, the height the rocket got stuck at was 30 feet above the ground. We have negative 16t squared plus the initial velocity they said was 64. And the initial height it was launched from was 2. So first we're going to subtract 30 from both sides of the equation. And we've got 0 equals negative 16t squared plus 64t minus 28. Not so much loving the negative, so I'm just going to divide both sides by, what can we divide out? Negative 4 will be nice. Now, we don't normally want to divide both sides of the equation if we're dividing out a variable, but we can divide out a constant, that's fine. So I have 4t squared minus 16t plus 7. So I need to come up with factors of 28 that are going to give me a sum of 16. 2 and 14. That was a good place to start. So I have 4t squared minus 2t minus 14t plus 7. Greatest common factor of the first two terms is 2t, so I have 2t minus 1 left. So I want to take out a greatest common factor of negative 7, because negative divided by negative is positive 2t, positive divided by negative is negative 1, and that's what I wanted. So I'm going to have 0 equals 2t minus 1 times 2t minus 7. So using our friend the zero product property, either 2t minus 1 equals 0 or 2t minus 7 equals 0. Add 1 to both sides, so I have 2t equals 1, divide by 2, t equals 1/2. Add 7 to both sides, so 2t equals 7, divide by 2, and we have t equals 7/2, which would be, let's just go 3.5 and 0.5. Now, if you think of what's happening with the graph, it makes sense that it's going to start at 0. Obviously, it never starts below the ground. And it's going to get up to 30 feet in half a second. It goes higher, up past 60 feet, and then it comes back down to 30 feet. And so it's going to stop here. So the total time traveled is the 3.5, and that was seconds. A model for the vertical motion of a projected object is given by the equation h equals negative 16t squared plus vts, where h is the height in feet, t is the time in seconds, and v is the initial upward velocity in feet per second, and s is the starting height of the object in feet.